Direct variation. Direct variation is a simple concept. We're on page 262 of your algebra book. The first thing I'm going to do is tell you what a direct variation is. It's a special kind of function that always goes through 0, 0. Always. It will be in the form of y equals k times x. Nothing's going to be added to the back. Just a 0. You can't have any other number back there. If there's any other number added to the end, then it's not a direct variation. The k value, I'm going to talk about that in just a second. If you're looking at a table of values and you're asked to determine whether it's a direct variation or not, you need to compare the ratios for each y over x pair. If the ratio each time, suppose it turns out to be 2/3. If it's 2/3 all the way through, then it's a direct variation. If it has the same ratio all the way through. And that value that you get is your k value. So let's look at some examples. The first one says, is this a direct variation? Well, we don't know yet. What we need to do in order to determine if it's a direct variation is we need to look at it in the form where the y part is isolated. So I've got to rearrange this. I want this whole part gone, so I'm going to subtract 5x from each side. Gives me 2y equals negative 5x. Then I'm going to divide by 2. So I end up with y equals negative 5 over 2x. Negative 5 over 2x. Now, compare it. Is there anything added to the end? No. So is this a direct variation? Yes. Let's double check it. Let's graph it and see what happens. Y equals negative 5 over 2x. And I'm going to graph it. And I'm going to have to hit zoom 6 to get back to the standard window. Does it go through 0, 0? It sure looks like it does. Let me look at the table. Does the table, let me put my table back on auto, and I want my table to count by ones. Does the table go through 0, 0? Yes. So is this a direct variation? Yes, it is. Well, let's look at the next one. You're going to have to isolate the y, so we want to rearrange it so it says y equals. I'm going to subtract 5x from each side. Now, you know you really can't subtract 5x from 9 because 9 doesn't have an x on it. So you're just going to write negative 5x plus 9. It doesn't. You're not really solving, you're rearranging here. Divide by 2 every single item, and we're going to end up with y equals negative 5 over 2x plus 4.5. So this is negative 5 over 2x plus 4.5. So what do you think? When you compare this to the one at the top, they're not the same. That's got a 4.5 added to the end, and it's supposed to be only a 0. So I don't think this is a direct variation. Let's look at it on the calculator. It's negative 5 over 2x plus 4.5. So let's look at the graph. Does it appear to go through 0, 0? No, it does not. Go to the table. What happens? Is it 0? Is the value 0? No, it's 4.5. So this one is no, it's not a direct variation. I want you to try number 2 and number 6 on page 264. Pause the video. Try those. Okay. We're right back at it. Here we go. It says, write an equation of the direct variation that goes through the point 4, negative 3. Now, let me tell you something. Your equation, it says y equals k times x. The only thing that you need to replace is the k. And k will always be the ratio of y over x. So if that's your x and that's your y, you plug those numbers in. That's negative 3 and that's 4. That goes in place of the k. The y and the x stay in the problem. It's negative 3/4 x. Now, is there going to be anything added on to the end? No. Remember what we said about direct variations. They don't have anything added to the end. They just have a number in front of the x, and it's the ratio of y over x. Now, you try number 10 on page 264. Go ahead and pause the video again. Okay, last type of problem here. They're going to ask you to study a table and decide if it's a direct variation. So in order to do that, we're going to use our ratios. Remember what I just told you about y over x is equal to k. It's called the constant of variation, and it should be the same for every pair all through the table. So let's set it up and see what happens. Y over x, that's 2.25 over negative 3. The next one is negative 0.75 over 1. Negative 3 over 4, and negative 4.5 over 6. Now, I'm going to put those in my calculator and check their values. 2.25 divided by negative 3. I get negative 0.75. Okay? Let me try the next one. Negative 0.75 divided by 1. I get the same thing. So far, so good, but they all have to match, every single one of them. Negative 3 divided by 4. Yes, that works. Negative 4.5 divided by 6. That works as well. So is this a direct variation? Yes. And do you know what the K value is? It's that same ratio you've been getting all the way through. It is negative 0.75. If you want to write it over 1, you can, or you could just leave it negative 0.75. So you actually could go ahead and write this equation, y equals negative 0.75x. Let's look at this one. Okay, we're going to make the ratios negative 1 over 2, 1 over 4, 3 over 6, 4.5 over 9. We're going to compare these ratios. Negative 1 over 2 is negative 0.5. 1 over 4, negative 0.25. We already know this is not a direct variation because those two didn't match. You can go ahead and write no because you know it's not going to work. But let's go ahead and look. 3 over 6 is 0.5 and 4.5 over 9 is 0.5. So those two matched, but that's not enough for us to say it's a direct variation. So I want you to try number 24 on page 266.